Have you ever used an app that just felt off? You know something's not right, but you just can't put your finger on why. Well, it turns out the answer is usually hidden deep down in its foundation, in something called database design. Today, we're going to pull back that curtain on this invisible architect that can literally make or break the apps you use every single day. So grab your magnifying glass. Our investigation starts now.
We've all been there, right? You swear you did everything correctly, but the app is just not cooperating. It feels like there's a ghost in the machine. And these little phantom bugs can be so frustrating, not just for us as users, but for the developers who are trying to hunt them down. So picture this. It's a classic example. You move, you go into your favorite shopping app, you update your address, you place an order, and it ships to your old place. Ugh. The user interface looked perfect, right? The confirmation email looked fine, but somewhere, the ghost of your old data was still lurking. See, the problem wasn't on the screen. It was buried deep in the data.
Okay, so let's put on our detective hats as we investigate this case of the ghost data. All the clues, all the evidence, it's all pointing to one main suspect, something called data redundancy. And this is the root cause of so many of these weird, unpredictable bugs. So what exactly is data redundancy? It's actually pretty simple. It's just when the exact same piece of information gets stored in more than one place. Think of it like this. Imagine a library with 3 different card catalogs, and each one tells you your favorite book is on a completely different shelf. Which one do you trust? And if you fix one, do the others just magically update themselves? Yeah, probably not. That right there, that's the heart of our problem. And this one suspect, data redundancy, is responsible for a whole crime wave of what we call data anomalies. First up, the update anomaly. That's our shipping address problem. You have to update the info in a bunch of different places and just hope you found all of them. Then you've got the insert anomaly, where you can't add, say, a new customer to the system until they've actually placed an order, which makes no sense. And finally, the delete anomaly, where deleting one little thing, like a single order, might accidentally wipe out the only record of a product's existence. Yikes. So how do we bring this suspect to justice? How do we restore order? Well, the number one tool in our detective kit is a process called normalization. And this isn't just some random cleanup. It's a systematic, step-by-step procedure for organizing our data to get rid of that redundancy and stop those data crimes before they happen.
Okay, so this right here, this is our crime scene. A classic, messy, unnormalized table. I mean, just look at all that repetition. John Doe's name and address are in there twice, just for one order. The product name, laptop, is also repeated. This table is a total breeding ground for those anomalies we talked about. If you change John's address in one row but forget the other, bam, you've got a problem.
Now, the process of normalization follows a set of rules called normal forms. You can think of them as the standard operating procedure for our investigation. First normal form, or 1NF, basically says one piece of info per box. Simple enough. Then 2NF and 3NF. They dig a little deeper. They're all about making sure that every piece of information is stored with the thing it's actually describing. So, for example, the product name laptop belongs with the product's ID, not repeated in every single order that ever included a laptop. It's all about creating one, and only one, single source of truth for every piece of data. So what happens when we apply these rules of order to our messy crime scene? Well, we don't just tidy it up, we completely restructure it. That one giant messy table gets broken apart into several smaller, cleaner tables that are all connected to each other in a really smart way. And boom, here's the result. Just look at this beautiful setup. We've got a customers table where John Doe's address exists in exactly one place. We've got a products table just for product info, and then the orders and order items tables just use simple IDs to link everything together. Now, if John moves, you update his address in one spot, and every single order he's ever placed is instantly linked to the correct, new information. Case closed on that bug. But hey, solving the case isn't just about one big, fancy technique. A truly great detective relies on a whole toolkit of best practices and good habits. These are the things that prevent crimes from happening in the first place. So let's look at some of the other tools every data detective needs to have. Now, this might sound kind of basic, but it is so important. Just look at the difference here. TBL1, that tells you absolutely nothing. But users, you know exactly what's inside. Clear, consistent naming is like writing clear notes on your evidence board. It just makes the entire system easier for everyone on the team to understand, to maintain, and to fix when things go wrong.
Here's another one, using the right tool for the job, or in this case, the right data type. Storing a simple 5-digit zip code in a field that's designed to hold a whole paragraph of text? That's like using a giant moving box just to store a single key. It's wasteful, it's inefficient, and it can slow things down. Choosing the right, precise data type keeps the whole database lean, mean, and fast.
And our toolkit has a few more must-haves. Primary keys are like the unique case file number for every single record. No two can be the same. Foreign keys are the threads that physically tie our evidence together between the different tables. They enforce those relationships we created. And indexing, indexing is like creating a super fast index at the back of a textbook, letting the database find information in a flash without having to read every single page. All right, so just when you think you've got this all figured out, every good detective story has a twist. We spent all this time learning the rules, how to eliminate redundancy and normalize our data, but sometimes a seasoned detective knows that you have to bend the rules for a very specific and very important reason.
And this leads us to a really critical question. Is that perfect, clean, normalized organization always the number one goal? I mean, what if there's another goal that in certain situations is actually even more important? And that goal is speed. Pure, raw, unadulterated performance. For some applications, like generating a massive year-end sales report from millions of orders, the time it takes to connect all those perfectly organized tables can actually become a bottleneck. Sometimes you just need the answer, and you need it right now. And that brings us to this crucial trade-off. Normalization, on one hand, gives you amazing data integrity. It's perfect for those day-to-day transactions, what we call OLTP. But it can be slower for really complex reports that need to read a lot of data. Denormalization is the flip side. You deliberately reintroduce a little bit of controlled redundancy to make those reads way faster. You might store the customer's name directly in an order table again, but only for a special reporting database. It's a conscious choice, and it's ideal for analytics, or what's known as OLAP. And with that, case closed. Our investigation is complete. We've seen the crimes that bad data can commit, we've learned the techniques to clean up the scene, and we've even learned when it's okay to bend the rules. So let's wrap this up with the key takeaways. So here's a practical checklist you can actually use. When you're looking at a database, ask yourself these questions. Am I seeing repeated info everywhere? Does every single table have a unique identifier? Are the names confusing? Are we using indexes to speed up common searches? And hey, if things are slow, was that trade-off into denormalization made on purpose? This is your guide for spotting the clues of good or bad design. Ultimately, it all just boils down to this. Good database design isn't some abstract, nerdy exercise. It has real-world consequences. It makes software easier to maintain, it lets it grow without falling apart, and most importantly, it ensures the data you're looking at is actually correct. It's the very foundation of a trustworthy application. So, the next time you run into one of those ghosts in the machine bugs, don't just stare at the screen, think a little deeper. And remember to ask the most important question of all. What's the story that data is trying to tell?